Hi, my name is Frank DeRose, and I will be giving a presentation on a TED Talk by Alan Adams, What the Discovery of Gravitational Waves Means. A little background on Alan Adams. He is an associate professor of physics at MIT. He studies theoretical particle physics with a focus on string theory. He is affiliated with the Center for Theoretical Physics and also the Laboratory for Nuclear Science. He earned his BA in physics from Harvard in 1998, his master's from Cal Berkeley in 2000, and his PhD from Stanford in 2003 before joining the faculty at MIT in 2006. So let me begin by first discussing what exactly gravitational waves are. They are a ripple in the fabric of space and time, essentially like an acoustic wave traveling from a guitar. They stretch and expand. So by that, when the gravitational wave passes by an object, what happens is the space and everything around it stretches in one direction and compresses in the other direction. So you get a stretching and expanding type of movement when the wave passes through an object. They are very weak, but fortunately they don't have to be strong to be detected by the equipment that's used for detecting these waves, which I'll discuss in the next slide. And listening to these gravitational waves can tell us about the collision of two black holes in the past. So the equipment used for detecting these gravitational waves is called the LIGO, which stands for Laser Interferometer Gravitational Wave Observatory, which is just a fancy way of saying machine that detects gravitational waves. The LIGO allows us to observe the unobservable universe, which is basically everything beyond our realm of vision in the universe, simply by listening to it. So in that sense, it acts more like an ear than an eye, and Dr. Adams will discuss that in more detail in his talk. And on September 14th of 2015, the LIGO, just a few days after being set up, the LIGO heard a chirping noise. And what it ended up being was a gravitational wave that was created at some point in the past by two black holes that were whirling around each other and eventually collided, which created the wave. Alright, so what is the importance of this LIGO and detecting these gravitational waves? Well, one, they prove Einstein's theory of the existence of gravitational waves, which he predicted over 100 years ago now, which I think is pretty remarkable considering the how vastly different technology was back then compared to now. Two, they help us explore the unobservable universe. And three, these gravitational waves can help explain the history of the universe. And some questions to ponder. How do we know what black holes sound like, and that the gravitational waves that were heard by the LIGO weren't created by something else, like two galaxies colliding or two large planetary bodies colliding? Two, how can we take this data and attempt to rewrite the history of the universe? And three, can we create our own gravitational waves to send out into the universe? Which I think would be pretty cool. That's it. Thanks for listening. Hope you enjoyed Dr. Adams' talk and my presentation.